Hello everyone. In this video I am going to demonstrate FSK or frequency shift keying based modulator using IC 555. So as you can see here, this is my setup and this is the frequency shift keying circuit. As you can see, the circuit is capable of generating two frequencies. One frequency is for logic 0 and another frequency is for logic 1. So as you can see here, this is the setup. First, let me show you the circuit diagram and explain the theory of operation. Then I will demonstrate the operation. So as you can see here, this is the FSK signal. You can see this is a waveform with a variable frequency. You can see. So when the frequency is high, we can interpret it with a logic 1, and when the frequency is low, we can interpret it with a logic 0. Again, when the frequency is high, we can interpret it with a logic 1. So let us look into the circuit diagram. As you can see here, this is the circuit diagram. So here you can see I am using 555 timer as an stable multivibrator. So what I am doing, I am using here two parallel resistances. You can see. So one resistance is in the circuit, and when there is a logic change, this resistance will also come in picture. When there is no logic change, this resistance will be out of picture, and when there is a logic change, this resistance will come into picture and they will be in parallel to each other. You can see. So this is how the circuit looks like. The circuit is an emitter follower. Here you can see the resistance is connected to the to the emitter of SL100 transistor. So this is an emitter follower. You can see. Let us look into the theory. So as per the theory, so whenever any resistance is connected here, whatever logic comes here, it will follow here. So this is an emitter follower here. So whenever there is a logic 1, whenever there is a logic 0, this resistance will be in parallel to this resistance, and whenever there is a logic 1, this resistance will not be in parallel. So as you can see here, these are the logic reports. You can see at logic 1 I am going to generate a frequency of 48 kHz, and at logic 0 I am going to generate a frequency of 12 kHz with a 10K resistance and 1.5 kHz with a 100K resistance. So I will be putting 10K resistance and I will be observing the results. So as you can see here, when I am using 10K resistance, I will be generating 12 kHz signal, 12 kHz output frequency. So as you can see here, when I am giving a high pulse here, when this LED glows inside, when I am giving a 12 volts here, so the voltage here will be 0. So when the voltage here will be 0, you can see this resistance will not be in picture and 10K will be in picture. So the frequency will be, you can see here at logic 0, it is 12 kHz. So when I am going to give a logic 1, whenever I am giving it off command, here it will be a logic 1, and when there is a logic 1, you can see this resistance will come into picture, and since 10K parallel to 1K is 1K, I will be getting 48 kHz logic signal. So this is how FSK signal works as per the theory. So let us look into the practical demonstration. So as you can see here, so this is the SL100 transistor, and I am going to fire this transistor with a logic 0 and logic 1, and I will be getting two different frequencies at the output. So now currently this LED is not glowing, and let us see the frequency. You can see on the multimeter I am generating 50 kHz, and I am generating a 6 volts DC here, and the frequency is 50 kHz. So let us trigger the circuit and we will be seeing a change in the frequency. Just a minute. You can see here there is a change in frequency. The frequency has dropped to 13 kHz. You can see now I am switching off. You can see this is 50 kHz again. Again I am switching on. It is 13 kHz. Back to 50 kHz. So let us look into the oscilloscope waveforms. So here you can see the waveform is 48 kilohertz. This is the 48 kilohertz waveform. So now you can see this is a 10 kilohertz waveform. 48 kilohertz waveform, and again it's a 10 kilohertz waveform. You can see 48 kilohertz, 10 kilohertz. So this is how the circuit works. I am getting two frequencies. So 10 kilohertz means logic 0 and 48 kilohertz means logic 1. We can design the demodulator accordingly. In the next video, I am going to design proper demodulator for this circuit so that we can detect the two logic states. Thanks a lot. Thanks for watching. Please watch the next video where I will be detecting two logic states out of these two frequencies. Thank you very much. Thanks a lot. Thanks for watching.